Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to keep talking about econometrics. I'm going to talk about properties of estimators, or I'm going to start talking about properties of estimators. So in this video, I'm going to talk about three main properties, talk about bias, variance, and consistency. And as we go through and I add more videos, I'll get into each of these more in depth. But as usual, timestamps are below if you would like to jump around, but let's go ahead and get right into it. So first, I'm going to leave out consistency for a hot second, and I'm just going to talk about bias and variance, which are two main properties. So let's suppose that we're continuing with our example we had last time that we've been talking about with regressing stress level and the number of cats. And so maybe I have some data. I've got the data that I showed in sort of those last videos, and I'm going to run this regression. I'm going to get an alpha hat. I'm going to get a beta hat. And suppose that I knew what the true impact of having an additional cat on your stress level was. I don't know how I know that, but suppose that I just have this crystal ball and I can tell what the true effect is. And suppose that I get that the true effect is -2. So our true beta is -2. Now in our sample, we got a beta hat maybe of 4, just to make up a number. That's different from sort of the previous examples. In this sample, I got a beta hat of 4. If I were to run this regression for all possible samples, then the variance in my estimated beta or my beta hat would be something like 5. Suppose that my expected value of beta hat was equal to -2. And so questions we can ask about this estimator are things like, well, is our beta hat a good estimator? Why or why not would this be a good estimator? What would it mean if I had some better estimator? What would it mean for an estimator to be better than beta hat? And so when we're asking these questions, we're not really asking questions about this particular sample. We're asking questions about how we get this estimate and how it would work in all possible samples, which is why they're called asymptotic properties rather than properties of a particular sample. And we're going to use things like bias and consistency and variance in order to answer these three questions where we're basically saying, well, is our estimator a good estimator or not? And could we have a better estimator? And so one thing that might be sort of different than what we're thinking about is when I say the variance of beta hat, what exactly am I talking about? Well, if I think about all possible samples, if I were to run this regression on all possible samples and I regress stress level and number of cats, you might think that this beta hat and all these samples follow some distribution, and so maybe it's normal. Maybe this distribution is centered because the expected value of beta hat is equal to -2, so it's centered at -2, and it's got a variance of 5. So maybe in our particular data set, we got a beta hat of 4, but maybe if we were to run this same regression on a different sample, we would get a beta hat of 10. Maybe on a different sample, we would get a beta hat of -4. All we're saying with the variance is, how is our beta hat distributed if we were to look at this regression over different samples and calculate a beta hat in each of those samples? So one way we can use variance to sort of get at this question of, is our estimator a good estimator, what would make a better estimator, is suppose our estimator is in red, and again it's centered over -2. The minus is kind of hidden, sorry about that. Maybe if we had a different estimator, which also had a normal distribution, but with a smaller variance, might look something like this blue estimator, where we have a smaller variance and we still have the same expected value. So you would say, well, maybe this is a better estimator because it has a smaller variance? Like, I'm not sure, but it seems to me that this would make a better estimator. And again, that's sort of the question we're going to ask in sort of these type of videos. Another property of estimators is called bias. And here, the way I've done it, we have an unbiased estimator, and let me explain what an unbiased estimator is. Again, I know that the true beta is supposed to be -2, and I know that my estimator, we said the expected value is also equal to -2. And so what we're saying is, well, if for all possible samples, the expected value is equal to the true beta, then we don't have any bias. It's an unbiased estimator. Suppose I had another estimator, maybe a green estimator, that also had a normal distribution, but maybe the normal distribution for the green estimator is something that, like, I don't know, beta is -10, then what we would say is, well, this green estimator is a biased estimator because the expected value of that estimator is not equal to the true beta. So really, when we think about bias, what we're thinking about is the expected value equal to the true value? And again, we don't necessarily know the true value, but sort of theoretically, would we get the true beta as the expectation of our beta hat if, again, we're doing this over all possible samples? You might think that both the red and the blue estimators are better than the green estimator because the blue and the red estimators are unbiased and the green estimator is biased. And then again, you've got two unbiased estimators, the blue and the red. So maybe you think the blue estimator is better than the red estimator because the blue estimator is still unbiased but it has a smaller variance than the red estimator. Now, one thing in econometrics, when we think about bias and variance, there's basically a trade-off between bias and variance in your estimator, and I'm going to show you both intuitively why that makes sense, and then I'm going to prove it using math. The third property of estimators is consistency. All consistency means is that the variance of our beta hat is going to converge in probability to 0. All that means is that as we add more and more observations to our sample that we're using each time, the variance should go to 0. So this is my variance in beta hat in samples with a low number of observations. When I increase the number of observations, my variance goes down, and sort of my distribution looks like this. And as I add more and more observations to each sample, my distribution is going to basically become sort of something like this, where it's a normal distribution with a 0 variance, and it's going to be centered. If it's centered at the expectation, then I have an unbiased estimator, and so it's consistent. And so we're going to use consistency, we're going to use bias, we're going to use variance a lot going forward. When we talk about sort of the OOS estimates, we're going to talk about IV estimates, and then every time we talk about an estimate, we're going to be thinking of bias, variance, and consistency. So if this was confusing, feel free to leave a question in the comments below. If you'd like to see something explained more in depth, also let me know in the comments. But if this video or these videos in general are helping you out, please like and subscribe. See you next time for another case of econ struggles.